Hello everyone, I'm here to show you today how to make a plasma cutter from Dead Space. Here's the result. As I get closer, I'm rotating the mesh attached to the gun to create a crisscrossing motion with line traces. Rotating the sockets, the line traces, and if I release the right mouse button, you can't fire. But once I click onto it, I'm using the FPS template because currently I don't really have like an asset to work with, like a plasma cutter asset to work with. So I'm using just a makeshift plasma cutter to with like similar functionality as an actual plasma cutter. So I apologize for the for kind of the not the greatest design I could pull, but I got the beams and I got the rotation. So if you ever have the plasma cutter asset ever, you'll know how to make it functional. And I'll show you how the decals are able to not fade away, because I remembered in the previous tutorials where I made a decal, right? I made a decal, but it would fade after walking away, after like, I don't know, 5-10 meters away from it. Now as I walk away, you can actually just see the decals from as far as you want it to be, so it doesn't break immersion. I'm going to teach you how to do that as well. Now first though, I wanted you to create a material, call it whatever, smoke trail or laser trail. I just call it smoke trail because it's translucent. And what you're going to do, you're just going to try to find a smoke trail that looks like this, a PNG smoke trail that looks like this. Which I know that there's one just floating around on the net somewhere. You can just like look up smoke trail and this will pop up and you can drop it in there as a PNG. And here it's basically this. Basically that. Now how I did that, I did like a blend overlay. Took a texture sample, got the RGB, plugged into the V3, and the base I just made the color light blue, like in the Dead Space, and I put it into the emissive color, and then I multiplied the alpha channel of the particle color, and I dragged into the B, and the RGBA of the texture sample I dragged into the A. I think in order to make a particle color, you just do it and you just press right click and just do particle color. Oh, you might be wondering, why did I downgrade to Unreal Engine 4 instead? Well, that's the way that they made the FPS template in the Unreal Engine 4 version, to me, I think is a little bit more user friendly as opposed to the UE5 version, which they use delegates and they use blueprints. You know, in this one they use C++ only. In the other one they use a mixture of blueprints and C++ using delegates. And I couldn't really work with that, so I couldn't really get the mesh of the gun in order to do what I wanted to do, so I regressed to UE4 because I would have to go into the code, create another mesh, and also the mesh is not created in C++ in the UE4 first person template, so I would have to work with it in Blueprint, and I didn't want to do that, so I reverted back to the Unreal Engine 4 version, which has the mesh declared in C++ and Microsoft Visual Studio declared in everything declared in Microsoft Visual Studio. It attached in Microsoft Visual Studio and everything, so I could work with it and with a C++ base instead of a Blueprint base. So that's why I reverted to Unreal Engine 4, because I couldn't get the mesh within Unreal Engine 5 first person template. And now this is how you make the what do you call it, the material. And I just set the surface and translucent and default lit and two-sided, always two-sided. In order to get the blend overlay, you just do this. You just right click and just type in blend overlay. You just type in the names here, and here is a param. I'm gonna do a 3. I think it's a 3 const 3 vector. Yeah, it's a const 3 vector. Is it? No, it's a parameter color, I think it is. Is it vector parameter? Yeah, it's vector parameter. So this is a vector parameter, that's a vector parameter, and just change the name of it. Right here. So that's why I'm using Unreal Engine 4 as opposed to Blueprint. I mean Unreal Engine 5. Sorry if that bugs you, if you feel like I'm outdated. I'm just using Unreal Engine 4 at the moment because it's more user-friendly for me. I do like how they did an Unreal Engine 5 template, that they actually implemented a pickup system where you actually pick up the weapon, as opposed to just having it attached to the skeletal mesh, and having it actually just attached to the skeletal mesh. Okay, and now I'm gonna show you how to make the cascade emitter. I'm not using Niagara because, and I'm just gonna use cascade. I'm gonna go even further back. So just click particle system, new particle system. And where it says required, you put in your smoke trail mat, kill on deactivate, kill on completed, and you create a source and target. There's really not much of a difference, so I think let's just do smoke trail mat. Smoke trail mat. We'll do that, and in the spawn, I think it's const 0. Spawn rate. Let's see. Yeah, it's at 20, so you set that to 0. Set it to 0. You right click here and you go to, what was it? Type data, collision, acceleration. Where were you? Somewhere around here somewhere. Parameter. Oh, beam data. Ooh. Oh, new beam data. There we go. Perfect. Now, beam data. You right click, go over here to particle system. You create new beam data, and it creates beam data over here. And let me go over here and just and the lifetime const 0. 0. Just put it 0. And then beam data source. I'm not going to put it as target, I'm going to put it as user set. And target user set. And the source name is none. What really matters is that with the source, it's user set, so I guess this doesn't really matter because this target distribution, this distribution vector constant, because it'll be declared in C++. So you just create new beam data, and the required, you put a smoke trail mat, you put kill and deactivate, you do a lifetime of 0, initial size of 20. That's what I put. You can make it smaller or larger, however you want. Start velocity 0, 0, 0, 0. Or the initial velocity is 0 across the board. You just do that. So there's no velocity because once it comes out of the socket that you're going to be using, really doesn't matter. And color over life, well, that doesn't really matter because the material is already set up to where it's capable of doing what you want, of giving the color that you want. So with the source, it's user set, target, user set. Target tangent method is user set. User set. Everything is user set. If you see anything here that can be changed, like target method and target tangent method, it's user set. Okay, now to activate that in C++ code, what you're going to have to do is you go to the plasma tutorial character, or plasma cutter tut character. You create U properties within the .h of the character, so that then you can grab this in any function. So it's a global variable. It's public. It's kind of, it's not the same as global, but it's almost the same. Public. It's a public variable that be declared throughout this entire actor. It's not the same though as global variable. Here you're gonna create the uStatic mesh component, call it FP gun rotator, the U particle system, trail beam comp 1, trail beam comp 2, laser trail beam comp 3. and you're gonna create a laser trail, a U particle system called laser trail, and create a U material instance called bullet hole. And in the build.cs, before I forget, you have to add the physics core, because we're gonna be using this material instance and spawning a decal on the mesh using a physical material and a physical material on the material. We're gonna be using surface types as well. So basically, to set up in the constructor, what you want to do, you want to create the FP gun rotator, create a default sub object, call it uStatic mesh component, and set up the attachment to the root component. The reason why I'm setting it to the root component, not the FP gun, is because in the begin play, I'm going to attach it to the muzzle of the FP gun. So on begin play, it will snap the target and it'll be the muzzle on begin play. And the laser trail beam component, you're gonna set these up. I recommend setting them up all at one at a time, because if you set these up like for some reason, when you set these up all at the same time, you just, like, for example, you were to take this code here and just compile it, it might crash the engine. I just recommend doing one at a time, or one laser trail beam at a time, and then set up the attachment one at a time, because it might crash the engine. From my experience with attaching these beam components, these particle system components, begin play, you're going to attach it to the muzzle, and within the delta tick, checking if lasers are active, which is the right click button, but I'll go with that a little bit later. You're gonna get the socket location of the plasma cutter one. You're gonna get the response params, plasma query params, default query params, and just the spawn params. And then with the plasma query params, you're gonna do bead return physical material is equal to true, like from the previous tutorial, the surface types tutorial, and the espawn actor collision handling method is going to be equal to always spawn, and the plasma query params is going to be add ignored component, and you're going to do the FP gun. You don't want to hit the gun when you fire the line trace. And the reason why I'm putting all this in the tick, I'll explain later. I'll explain after I'm done looking through this code here. Get the socket location. It's almost all the same here. Or is almost all the same. And the current rotation, get the socket rotation. And the plasma in trace. And here's the current rotation. I just create a local variable of the current rotation instead of just creating it inside the public class, inside the .h file, because I'm only using the second rotation and the third. The plasma cutter, the current rotation of the second and the third. I'm not using the first because the first rotation is not really relevant to any of this. It's not really extremely relevant. And here is I'm not really casting a line trace here. What I'm doing, I'm declaring all these variables so that then I can activate the system here and set the source beam point and the target point in order to activating the system. And then once I release the right click, it deactivates, sets the visibility to false, deactivates, and sets the visibility of the laser trail beam to false. The reason why I didn't tick is kind of an improvement from the smoke trail tutorial that I made, because I noticed that the smoke trail would deviate from the socket and it wouldn't stay where the socket was located. So that is why I'm using tick, because every frame it will reattach itself to the socket. It won't have to jitter. And I know that using tick is bad, but in this instance, I don't think there's any other way, because I tried using a timer. When I tried using a timer, it would jitter, jitter along the socket, and it would move away from the socket. So that's why I'm using the tick. And I know using tick is bad practice, but I guess for something like a design asset like this, maybe it's not that performance impactful. I don't know. If there's a better way of doing it, please put that down in the comments below, because I would like to optimize the code if possible. I tried using a timer, and the plasma start trace or the socket location wouldn't follow the trail of the beam as well. So that's part of the reason why I made this tutorial, because it's kind of a follow through on the smoke trail tutorial, on the smoke trail array tutorial, and this is an improvement, I believe. Checking if lasers are active, and then I'm getting the socket rotation, getting F hit result, getting the current rotation, basically creating a line trace. I'm just gonna create a line trace single by channel, get the hit 1 plasma start trace, plasma end trace, set the visibility to ECC visibility, set the plasma query params. Here I'm spawning a decal actor, and within the decal actor, I'm getting the hit location. I'm setting the rotation to 90 degrees on the pitch, because if I don't do that, the decal will be a square. And then I set the decal material to bullet hole. Get decal set screen fade size to 0. Get the decal, set the decal size to 4. And do the same with the hit 2. Ooh, I'm gonna get rid of this because that's not unnecessary. And getting the line trace single by channel here, getting the hit 3, and getting the hit 3 physical material surface type. And after you add that physics core to the build.cs, you want to rebuild the entire project. You want to click here, build, and do rebuild, so that then this will be included in the build process. Fires off the fire sound and the fire animation. I don't have any for this because I don't want to deviate the line traces because of the animation. Oh yeah, also this doesn't matter. You can just switch this back to the first decal actor, because you can use the first decal actor to spawn. You can reuse this bullet decal actor that I had created in C++. I'm setting as a material here. And rotating the socket. Has rotated, false. I created a boolean called has rotated, and I'm setting equal to false. Setting the relative rotation to 0, 0, 0. And then else, setting the relative rotation to 90 on the roll, then setting it back and forth based on the boolean. And what I'm doing, I binded 3 new actions: rotate socket, activate laser trails, activate lasers, and deactivate laser trails on released. Here are the variables again. Don't need that. Not using a timer. I'm using the event tick. So basically, after all of that creation, all that variable creation, and also I forgot to mention, you have to create the decal actor. This is called bullet decal actor. Ignore this, just create one decal actor and spawn it. You don't really need to put anything inside this decal actor, just create the decal actor and then spawn it via C++ and setting it via C++ during runtime. Gain the hit, gain the physical material, gain the surface type, checking the surface type. Also, in order to create the surface type, go down here, go to project settings, surface type, type in surface type in the detail section, call it cube material. And then what you want to do, you want to create a folder, maybe call it physical material. Do a right click, physics, physical material, create it, call it whatever. Go in here, set the surface type to cube material. And there you go, you have yourself a physical material. Then in order to set that inside the material again, in order to set this inside the material, what you do, you click on the actor itself, go down here, go where it says cube material, and set the new physical material to whatever you called it. What matters is the surface type within the physical material. So it's cube mat. Its surface type is cube mat, and then within the blueprint class, within the first person CPP here folder, and here the plasma cutter tutorial character, you want to set it up. You don't really need the fire sound, the fire animation. That's ambiguous. It really doesn't matter. It's just that you can put your own plasma cutter sound, plasma cutter animation, whatever you want to call it. Well, since we're using the first person template, this would be irrelevant. This would be relevant. The fire sound would be relevant. And then you take the laser trail, set the smoke trail, set the bullet hole metal, set the decal to whatever you have as a decal. Which I did get a decal pack. So if you have any decals, just create like a very simple decal, Photoshop or whatever you want, and slap it in here, slap the texture in here, and create a material out of it. It doesn't really matter. And then on the FP gun rotator, I attached all of the laser trail beam components to the FP gun rotator. And I attached the FP gun rotator to the mesh, to the FP gun. I mean, I didn't attach it. Sorry, I'm gonna attach it during the begin play, during runtime. Set that to smoke trail. Set that to smoke trail, and set that to smoke trail. Set all three to the smoke trail. And then within the cube, I used the cube for this. You can use whatever you want. I used a cube, and where it says down here, create socket, and you name it the plasma cutter 1, plasma cutter 2, and plasma cutter 3. Delete it, and then what you do, you move those sockets adjacent to each other. So I put plasma cutter 1 in the middle, I put plasma cutter 2 off to the side here, and I put plasma cutter 3 off to the side here. And I'm checking along the x-axis. You want to keep the socket's rotation x-axis pointing outwards. And these sockets will move with the size of the cube, so don't worry if you're gonna resize the cube inside of the viewport. It will follow it. Like right now, this looks kind of ridiculous and funny at the same time. It looks kind of ridiculous, but the reason why in the during begin play that the mesh that the gun itself does not, have a humongous cube sitting over it is because I set the muzzle here. I set the muzzle and then I create a preview mesh, and what you do, you add a preview asset to it, and I just added the cube to it, and then I rotated the muzzle, moved the muzzle, shrunk the cube on the muzzle, so then during runtime, in the begin play, the cube would snap its location, rotation, and its size to the muzzle. So now that's how you do it. You just right click, add a preview asset, call it cube, and then you do that. And is there anything else? Also, if you so happen to have any issues with the editor, the blueprint class itself, you're gonna have to delete the blueprint class, and you're gonna have to assign everything again, depending on your hardware. If your hardware's not that good, you're probably gonna have to perhaps, if you notice it crashing, you're probably gonna have to delete the blueprint class and recreate it, and then set everything. So to auto possess player, you set that to 0 and set it's the place in the world of spawn. So if you're running into issues where you're gonna do event begin play, and you notice that it crashes, and it's because of something you set in the constructor, it's because the blueprint class conflicts with what's ever in Microsoft Visual Studio, and that creates a confliction, and then it causes the engine to crash. And if you notice that the constructor, when the engine crashes and it says like line 22 on .8 on .cpp constructor line 22 or line 33, you're gonna have to delete this blueprint class by right clicking, deleting, and then creating a new blueprint class and resetting all those variables all over again by doing create blueprint class based on the character again. Or you can do it this way, which is another way. You do blueprint class, you go where it says all classes, and you see where it says pick parent class. You type in the search bar plasma cutter tutorial character, my plasma cutter tutorial character, and you set that as the parent class, if that's the name of this. No, it's just plasma cutter tutorial character. My plasma cutter tutorial character is, oh yes, that's the name of it. Set blueprint class to the plasma cutter tutorial character. I just called my. I should probably rename that, but I'm not going to, because I don't want to really mess with this, because any little thing you do could have backlashes. So now, once you press the control key, it rotates the socket appropriately. Also, I set up the input actions. To rotate socket as left control, to activate lasers as or the right mouse button, and deactivate lasers to the right mouse button because you're releasing it. Excuse me. So here's the activate, deactivate, deactivate, rotate socket. And with the effects, here's one cascade, one matte, and one texture. And for the decal, well, you can create whatever decal you want. You either get off the marketplace or don't. You can create it using Photoshop or however you want to make the texture. And that'll be it for this tutorial. I hope you enjoyed it. If I missed anything, leave a comment in the comment section down below, and I'll try to rectify that. As you notice, the decals now just kind of, they stay there, they don't fade out. Okay, that'll be it for this tutorial. I'll see you guys later. Have a good one. Stay safe out there.